Hi friends, and welcome to this session on data interpretation. So this essentially is our first session. I know we have already done one session which is on the graphs, but this is more preliminary even before doing the graphs, right? So if you have already seen the video on graphs, I would request you to see this video first and then again redo the video on graphs, right? So firstly, let's understand what is data. So any processed information which you would get in a piece of table or in a graph or something like that is data, right? So for example, data of population of a particular state during various years, or data of, let's say, population of India from 2001 to 2008, or data of, let's say, Delhi from the year 2001 to 2015 and so on. So this is data, right? So data can be macroscopic, as it can present a larger picture, for example a picture of India or picture of population of, let's say, world, right? So that's macroscopic data. Or it can be as macroscopic as budget of a family, right? So it's data nevertheless, and we have to interpret that data as well, right? So data can be data, it can be microscopic, it can be macroscopic, it can present a very large picture, or it can present a very small picture as well, right? So for example, there are industry wide datas. For example, there can be a data of how oil and gas industry is working, what are the parameters which are affecting the industry, for example the crude oil pricing, right? Or there can be data as small as a particular refinery, right? For example, what is the problem in that refinery, is what is the input and output costs in that refinery. So that's the data of that particular refinery. It would tell us about that particular refinery, whereas data of the entire sector would also include the things which are happening in that refinery, right? So what do we need out of this data? Why do we need data interpretation? Actually, data interpretation tells us lots of things. It tells us lots of trends. So trends is an important word. We have to understand trends. We have to see what is happening with the data. For example, if you look at the population data of Scandinavian country, for example Switzerland, it would be decreasing. The trend is downwards, right? So there is decrease in the trend of population. So there the legislatures are worried about how to increase the population, whereas in India, if you look at the population figures, the trend is on a higher side, which is population is increasing each year, and our worries are different from what is there of a Switzerland, right? So we have to take care of these trends and decide likewise. All the policies, all the parameters, all the decisions would be based on these datas, right? So I have taken a small example so that the concept is driven home. So this is year 2001 to 2008. I have taken GDP of a fictitious city. It's 5,000. It varies from 5,000 to 9,200. The population of the same city during this time varies from 2,000 to 5,700, right? Now if you see this data, these are just mere numbers, right? Can we draw some inferences out of it? Can we look at the data and say something about it? Right? We can definitely look at the GDP numbers and say that GDP is increasing from 2001 to 2005, and in 2006 it decreased. Now why was this decreased? This decreased might be due to a recession, right? So this is called inferencing from the data. We are getting information out of this data. Similarly, if you look at the population numbers, you would see the population numbers are always increasing, right? So the population from 2001 to 2008 is always increasing. So while interpreting the data, we would be interested in year-on-year growth. For example, from 2002 to 2003, what is the growth of the GDP, right? From 2005 to 2004, what is the growth of the GDP? We might be interested in cumulative growth rate as well. So for example, what is the growth rate from 2001 to 2008? So this is called cumulative growth rate, because we are taking all the growth of the entire years in between, right? So that's the cumulative growth rate. We might also be interested here in the maximum growth rate. When was the growth rate maximum? So we have to find year-on-year growth rates and compare them. For example, example, here if you find the growth rate from 2000 in 2002 vis-a-vis 2001, it would be 500 divided by 5000 into 100, right? So this would be the growth rate, and so on and so forth, and then we will compare and find the maximum growth rate. Then our concept of ratios might also be used in. So now what we are given is GDP and population. We can infer or we can derive a parameter out of this, which is the per capita income, right? So per capita income would be, so in question itself there can be a formula given that GDP divided by population is the per capita income, and we have to use that formula to derive per capita income each year, right? So that's the application of another concept which we learnt, ratio, right? So we see that growth rate is application of nothing but percentages, right? So we see that the concepts of percentages, ratios, which we have already done, are very frequently used here. That's why if you remember clearly, I told you to learn the ratios, right? To learn the fractions from 1 by 1 to, let's say, 1 by 20, and also learn to convert them into percentages, so that you can seamlessly switch from percentage to fraction and fraction to percentages. So you can see that would come very handy here, and you would be able to do questions only very fast only if you remember these things, right? So we would be interested in average of, let's say, what is the average of average GDP from 2001 to 2008. We can be interested in average per capita income from 2001 to 2008, and so on and so forth. So cumulative growth rate we have already mentioned, we would be interested in this. So this is the normal data, right? Normal tabular form of data. We have already seen that we can represent the data in various graphs as well. So few popular graphs are line graphs, which we have already seen yesterday in the last session, that there can be line graphs. Then the other popular form of graph is bar graph, right? So we would see the graphs, the bar graphs, in coming few lectures. And then there could be pie charts, and so on and so forth. So these are some of the few popular things. So bar charts, line graphs, pie charts are few more seen graphs, and you would find questions based on these graphs very frequently, right? So if you see past year papers, you would invariably find question based on line graphs or bar graphs or pie charts, right? So we would take these graphs one by one, we would build in caselets around them. So you would find usually the questions are in caselets, that is, there would be 4 or 5 questions based on a particular set of information. The questions can be based on a table like this, or a mixture of a table and a graph, or mixture of 2 graphs, and you have to construct and interpret the data accordingly and answer the questions. But this is the basic terminologies which we would be going to use: year-on-year growth, cumulative growth rate, average growth, right? Average GDP, for example, in this question, and all that stuff. And this would be the parameters which are most frequently asked in the questions, right? So I hope that you are well versed with now the basic terminologies, why are we doing the data interpretation part, and what can be expected out of it. So with this we'll end this session, and in the next session we would do the graphs, various kinds of graphs, and we would perhaps do some caselets and understand how to solve them. So thanks for watching this video, and all the best for your preparations.